Good morning, students. So today we will discuss the another important topics of physics, that is units and measurements. And first of all, let us see what is the physics. Okay, and physics, basically we have the branch of science concerned with the nature and properties of matter and energy. Subject matter of physics includes mechanics, heat, light, and the radiations, sound, electricity, magnetism, and the structure of the atom. Then next we have the measurement in everyday life. So measurement means anything which we measures, like mass we measures, volume we can also measure. So these are the two example of measurement. Okay. Then we have another example of measurement, that is measurement of length, and again measurement of temperature. And these are the examples of measurement in everyday lives. And then need for the measurement in physics. What is its needs? To understand any phenomena in physics, we have to perform experiments. Experiments require measurements, and we measure several physical properties like mass, length, time, temperature, pressure, etc. Experimental verification of laws and theories also needs measurement of physical properties. Then next we have physical quantity. What do you mean by physical quantity? A physical property that can be measured and described by a number is called a physical quantity. Okay, some examples of physical quantity like mass. Okay, mass of a person, like we say that 65 kg, length of a table is 3 meter, area of a hall is 100 meter square, and temperature of room is 300 degree Kelvin. So these are the example of physical quantity. Then we have next we have like meaning of mass. What do you mean by mass? Mass is basically the measure of amount of matter and amount of matter in a body, and it is usually denoted by small m, and or it can also be denoted by capital M. Okay, and then weight. How we can differentiate the weight from mass? That's weight. It can be defined as the measure of the amount of force acting on a mass due to the acceleration due to gravity, and weight usually is denoted by capital W. Weight is mass multiplied by the acceleration gravity. So this is the relationship between weight and mass. So we can define as weight equal to mass multiplied by the acceleration of the gravity. So this equation basically defines the relationship between weight and mass. Then we have next we have types of physical quantity. Okay, type of physical quantity. First one is fundamental quantity. Physical quantities which do not depend on any other physical quantity for their measurements are known as fundamental quantity. Like examples of fundamental quantities are mass, length, and time, temperature. These are the examples of the fundamental quantity. Next we have second type of physical quantity, derived quantity. Physical quantity which depend on one or more fundamental quantities for their measurements are known as derived quantity. And examples of derived quantities include area, volume, speed, and force. These are the example of the derived quantity, which is second type of physical quantity. Okay. Then next is the units for measurement. Okay, units for measurements. Standard used for the measurement of physical quantity is called a unit. So basically, unit is a standard for the measurement for any quantity. We have the standard, and in that standard we measure the quantity. So examples: meter, foot, inch for length. We use meter, length, foot for length measurement, and for mass measurement we use the units kilogram, pound, and for time measurements we use second, minute, hour, and for temperature measurement usually we use the unit Fahrenheit or Kelvin. So these are the different types of units for the measurements in physics. Then we have the characteristic of units. So first one characteristic of unit is it should be well defined, and second characteristic is that of suitable size. It should be reproducible, invariable, indestructible, and internationally acceptable. So these are the some characteristic of the units. Then next we have CGS system of units. So CGS system of units, it was first introduced in France, and it is also known as Gaussian system of units, and it is based on centimeter, gram, and second. Okay, so CGS basically stands for centimeter, gram, and seconds as the fundamental units of length, mass, and time. Okay, so fundamental units of length, mass, and time, they define the CGS system. So C stands for centimeter, G stands for gram, and S stands for your second. Then we have next type of system, that is a MKS system of unit. MKS system of unit. So this we can define like this system was introduced in France, and it is also known as French system of unit. It is based on a meter, kilogram, and second. Okay, M stands for meter, kilogram, K stands for kilogram, and S stands for second as the fundamental units of length, mass, and time. So this is another system of units. So we have we have two system of units. One is CGS and MKS system of units. And next another type is FPS system of units. And in case of FPS system of units, it was introduced in Britain. It is also known as British system of units. It is based on foot, pound, second as the fundamental units of length, mass, and time. Then international system of units, SI. SI stands for International System of Units. In 1971, General Conference on Weight and Measures had its meeting and decided a system of units for international uses. This system is called International System of Units and abbreviated as SCI from its French name. The SCI unit consists of 7 fundamental units and 2 supplementary units. Okay. Then we have 7 fundamental units. So this is a table which is showing fundamental quantity as a unit and their symbol. So we have the 7 fundamental quantity like length, mass, time, temperature, electric current, luminous intensity, amount of substance, and accordingly in the second column we have their SI unit like meter. Length is expressed in a meter and its symbol is m. Mass is expressed in a kilogram and its symbol is kg. Time is expressed in second and its symbol is s. Temperature is expressed in Kelvin and its symbol is K. Electric current is expressed in ampere and its symbol is capital A. Luminous intensity is expressed in candela and its symbol is CD. Amount of substance is mole and its symbol is MOL. So we have 7 fundamental units which are there in physical measurements. Okay, these are very important. Then definition of meter. What do you mean by meter? Meter is basically the length of the path traveled by light in a vacuum during the time interval of 1 by 299792,458 of a second. So this is the time interval. You can see how small it is. No, it is 1 by 29 time of a second. So this is the meter. Then definition of a kilogram. Kilogram is the basically mass of prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weights and Measure at Sevres near Paris. Okay, this is the definition of kilogram according to this International Bureau. This is a prototype cylinder of platinum iridium alloy. Okay, so this is preserved in Paris, and it is preserved by International Bureau of Weights and Measure. It is located in Paris country city. Then next we have definition of second. 1 second is time taken by 91926317770 oscillations of the light emitted by cesium-133 atom. Okay, so basically giving you the number of oscillations of the light which are emitted by one particular type of atom, which is cesium-133. So this is the definition of second. Then 2 supplementary units are also there in your physical measurements, units and measurement. 2 supplementary units are there. One radian, like it is first one supplementary unit, radian. it is used to measure the plane angle. So figure is showing a plane angle, so theta means it is a plane angle, and a and b are some points, and r is some radius curved path, and r is the radius, okay, and o is the center of the circle, so theta is 1 radian. Okay, so this is how we can define the radian. Then stadian. Okay, next type of supplementary unit is stadian, and it is used to measure solid angle. Basically, radian is used to measure the plane angle, and stadian is used to measure the solid angle. So theta is your, it is denoted by this ohm symbol, you know, ohm is 1 stadian. So it is usually expressed by this ohm symbol and shown in this figure, like and it is used for solid angle measurements. Okay, then rules for writing these SI units, system international units. What are the rules? Full name of unit always start with small letter even if named after a person. Okay, full name of a unit always starts with a small letter if named after a person. So on the left side you can see full name of the unit, it is started with a small letter like Newton, Ampere, Coulomb, and on the right side it is the name of the person. N is the Newton, A Ampere, and Coulomb. It is denoted by capital letter. Then second rule, symbol for unit named after a scientist should be in capital letter. It is a symbol, so it should be in capital letter, like capital N it should be for Newton, capital K it should be for Kelvin, A for Ampere, C for Coulomb. So these are the symbol for unit which are named after a scientist and they are in capital letter. This is the second rule for writing the SCI unit. Then third one, symbol for all other units are written in small letter, like small meter, second, kilogram, candela. These all they are written in small letter, like M, kg, S, and cd. These are the symbol. And one space is allowed left between the last digit of a numeral and the symbol of a unit. So one space is written 10 kg, 5 Newton, 15 meter. Okay, so space should be there. This is also one of the important rule, like last digit of a numeral and the symbol of a unit. There should be one space. Okay, no, it should not be written like this 10 kg, 5n, and 15 meters. So this left one, it is correct one. Then fifth one, unit do not have plural forms. The units do not have a plural forms. So you can see the units do not have plural form in this slide. Okay, then next we have another one is your just a minute, full stop should not be used after the units. Okay, so after the units full stop should not be used like this. Here it is using the full stop. So this is not correct one. Then next, no space is used between the symbols for the units. Then next rule, some SI prefixes are given, like you can see 6 columns are there, factor is given, then their name, symbol, factor, name, and symbol. Like we express 10 is to 1 deca, 10 is to 2 hecto, 10 is to 3 is expressed by kilo, 10 is to 6 expressed by mega, 10 is to 9 expressed by giga, 10 is to 12 tera, 10 is to 15 by peta, 10 is to 18 by exa, 10 is to 21 by zeta, and 10 is to 20 by iota. So these are the factor and their name, and correspondingly their symbols are also written as you can see in these slides. Okay, then next we have uses of SCI prefixes. Like if we write 3 milliampere, then we can express it like 3 mA and 3 into 10 is to minus 3 ampere, 5 microvolt it is usually written like this: 5 microvolt, 5 into 10 to the minus 6, 8 nanosecond, it is written like this. No? So these are the uses of SI prefix. So it is very simple. Then next we have some practical units for measuring length. Okay, 1 micron, like we can write it as 10 to minus 6 meter. 1 nanometer, 10 to minus 9 meter. These are some practical units, you know. So these are for bacteria and molecules, you can see. Then some practical units for measuring length, like 1 angstrom, you know. 1 angstrom, it is usually written by 10 to minus 10 meter. It is for atom, you can see here, it is for atoms. And 1 Fermi, 10 to minus 15 meter, and it is expressed by nucleus. It is for nucleus, you know, Fermi. So we can define one astronomical unit, you know. So this is also practical unit for measuring the length. So what is astronomical unit? It is defined as the mean distance of the earth from the sun. Okay, what is the mean distance from the earth to the sun? That is the astronomical unit. And one astronomical unit, it is equal to 1.5 into 10 to the power 11 meter. Okay, so this is very important unit of the measurement. Then another important one is light year. You can see light year, it is the distance traveled by, it is the distance traveled by light in vacuum in 1 year. Okay, so 1 year means 1 light year, 9.5 times to 15 meter. So this is also important. Then some practical unit for measuring the mass, like 1 metric ton, we can also write it as 1000 kg, 1 quintal, 100 kg. These I think we are very much familiar with these practical units for measuring the mass. Then some other important thing, like 1 solar day, 24 hours, 1 sidereal day, 23 hours and 56 minutes, 1 solar year equal to 365 solar day equal to 366 sidereal day, and 1 lunar month equal to 27.3 solar day. 1 shake is equal to 10 to minus 8 second. So these are the some practical unit for measuring the time. Okay, then some dimensions of the world. Some dimensions of the world means length, it is the fundamental quantity and its dimension is L. And then mass, its dimension is capital M. Then time, it is expressed in T, temperature for K, current for ampere, amount of distance by your amount of substance by N, and luminous intensity by J. Okay, so these are 7 dimensions of the world. Dimensions of the physical quantity, which is the next one, and we can define as the power of the fundamental quantity in a derived quantity, are called dimensions of that quantity. Okay, dimensions of the physical quantity. So one example we can take, like if we write like this, you know, the density, we can express density as mass equal to mass divided by volume. So mass as it is. So what is volume? Length into your breadth into height. So this is length into breadth into height, that is the volume. So mass, it's expressed, it can be written as M. So length is L, breadth is again L, and height is also L. So we can write it as M by L cube. Okay, so this becomes M times L raised to minus 3. So dimensions of its density are 1 in mass and minus 3 in length. Okay, so we have seen how the dimensions of the density are written, how they are calculated. So it is 1 in mass, like M is there, and L is to minus 3 in length. Then uses of dimensions. What are the uses of the dimensions? First one is to check the correctness of the equation. Second use is to convert the unit, and third use is to derive a formula. Then to check the equations. Okay, first one, how we will check the correctness of the equation? We have considered the simple example. We have considered a simple equation like which is equation of the displacement, and it is here, it is given delta x is equal to VIT plus 1 by 2 AT square, and we write the dimensions for both sides. Okay, delta x is the displacement. Okay, so for displacement means L. Okay, its dimension is L. Then VI into T means velocity into time. So this is length by time into time, because we know that velocity can be expressed as distance upon time. So distance is L divided by time. So length by time into time, it becomes length. AT square means acceleration into time square, and this becomes length by time square into time square. This becomes L. Okay, so we have seen that what are the dimensions of the delta x means L, and what are the dimensions of VAT? L. Then AT square L. So dimensions of each term are same. If we verify from both sides, like L is on the left side, and for right side, if we verify the dimensions of the right side, and if we verify the dimension of the left side, both are same. So we say that this equation is dimensionally correct. Okay, so this is also one of the important use of the dimensions. Then if you want to convert the units, second use, so second use means if we want to convert the units, let us convert Newton, like Newton SI, which is SI unit of force, into dyne, which is CGS unit of force. Okay, and we know that the dimensions of the force are LMT minus 2. So 1 Newton is equal to 1 meter multiply 1 kilogram 1 second whole square. Length is for 1 meter, mass is for 1 kilogram, time is 1 second per square. And 1 dyne. Okay, but dyne, what is dyne? Which is CGS unit of force, that is 1 centimeter into 1 gram divided by 1 second whole square. So 1 Newton by 1 dyne, this is equal to dividing both sides. Okay, 1 meter by 1 centimeter, 1 kilogram 1 by gram, and 1 second by 1 second whole square. So we can calculate. Okay, so this becomes, after computing and after simplification, you will get 10 raised to 5. So we can say that 1 Newton, this is equal to 10 raised to 5 dyne. Okay, so in this slide you can see how the Newton is converted into how the Newton, which is SI unit of force, it is converted into dyne, which is a CGS units of force. Okay, so in this way we can convert the units. Then next one is we can say one example here, another use like to convert the units, and these are two, in brief we can say, uses of the dimensions. Okay, so first use we have seen to check the correctness of the equation, and second use we have seen that to convert the units. So in this way the dimensions of the units are useful, and we can check the correctness of the equation, and we can also convert the to make a conversion between the units, how the Newton is to be converted into dyne and how the dyne is to be converted into units. So this is all about the units and measurements topic. This was the introductory lecture. So any doubt you can make the comment and let me know if you like the video, and do you have any query, you can make you can put the comment in the comment box. Okay, so the remaining next topic of this units and measurement chapter we will see in the next video. Okay, and then thank you.